Are we inside one universe or just one bubble? Have you ever paused and wondered, why is there something instead of nothing? Why does the universe exist at all? And even crazier, what if our universe is not the only one? What if everything we know, all of space, time, matter, energy, physics, galaxies, is just one bubble floating inside a much larger cosmic foam? The Big Bang Theory is the most successful explanation of how our universe evolved, but it doesn't explain how it started. We can trace cosmic expansion all the way back to a tiny fraction of a second after the beginning, but the moment before that is hidden. This mysterious wall is called the cosmic horizon. It's like trying to watch the first scene of a movie that's been burned off the film reel. Scientists realized this gap, this silence, this mystery might hold the key to something bigger. That's when the idea of cosmic inflation arrived. Today, we're going on a mind-bending journey beyond the Big Bang into the mysterious world of the multiverse, one of the most fascinating, controversial, and thrilling ideas in modern science. In the 1980s, physicist Alan Guth proposed inflation, a moment when the universe expanded faster than the speed of light, not because it wanted to, but because space itself was stretching. Inflation explained the uniformity of the universe, the cosmic microwave background, the distribution of galaxies, why space is flat. But then something wild happened. Inflation predicted that space shouldn't just expand once, it should expand forever, in different pockets, at different times. Meaning, our Big Bang might just be one firecracker in a cosmic fireworks display. This idea was called eternal inflation, and it naturally leads to a multiverse. The easiest multiverse to understand is level 1. It simply says, if the universe is infinite, then everything that can happen happens somewhere. Your life, your decisions, your choices. There's another version of you out there in a different cosmic neighborhood who made the opposite choice. This isn't fantasy, it's mathematics. If particles can only be arranged in a finite number of ways, then in an infinite universe, arrangements must repeat. So somewhere extremely far away, there is a region of space identical to ours. Is that a different universe? Or just a distant part of this one? That all depends on where you draw the boundary. Now it gets interesting. Inflation suggests our universe is just one bubble inside a frothy cosmic sea. Each bubble has its own Big Bang, its own physical constants, its own chemistry and structure, even its own number of dimensions. Our bubble forms. Inflation slows. We get stable physics, stars, life. Another bubble forms. Inflation slows differently. Maybe gravity is 10 times stronger. Maybe stars burn out instantly. Maybe atoms can't form at all. In some universes, the laws of physics make life impossible. In others, they might create creatures we can't even imagine. Carl Sagan once said, "The universe is not required to be in perfect harmony with human ambition." Level 2 is the multiverse that challenges human specialness the most. If you really want your brain to melt, welcome to Level 3, the quantum multiverse. According to the many worlds interpretation, every quantum event, every tiny particle decision, splits reality. When an electron goes left instead of right, reality branches. When you choose one path, another you chooses the other. Not metaphorically, literally. We don't see these universes because they exist in separate quantum branches, mathematically orthogonal to ours. Physicist Hugh Everett said, "Reality consists of a multitude of universes." If true, the number of universes is not just huge, it's infinite, forever branching, forever multiplying. Finally, the most extreme multiverse idea, the mathematical universe hypothesis, proposed by physicist Max Tegmark. He believes mathematics is not just a tool, it is the fundamental reality. Meaning, any universe that can exist mathematically does exist. Even universes with bizarre physics we can't imagine, universes with different types of time, different numbers of dimensions, different mathematics entirely. If level 4 is true, our universe is just one equation inside an infinite library of equations. The multiverse raises profound questions. If there are infinite universes, is our existence just a cosmic accident? Or does the multiverse solve the deepest mystery of all, the fine-tuning problem? Why is our universe so perfectly calibrated for life? If just one constant changed, life wouldn't exist. The multiverse offers one answer. Out of infinite universes, some must allow life. We're simply inside one of the rare universes where life is possible. Just like fish live in water because that's where fish can survive, we exist here because this bubble is friendly to consciousness. It's not design, it's not luck, it's selection. Many scientists argue against the multiverse. Some say, if a theory predicts universes we can never observe, is it really science? Others argue the opposite. The multiverse isn't a random idea. It falls out of existing theories like inflation and quantum mechanics. In science, the real question is, does the theory explain reality better than the alternatives? Right now, the multiverse is one of our best attempts to explain the Big Bang, fine-tuning, and quantum weirdness. So, after all this, the question remains, do other universes actually exist? And here's the honest, thrilling truth. We don't know, yet. But the clues are piling up, and they're becoming harder to ignore. Let's break it down. Clue 1. Physics doesn't forbid it. Science has a strict rule. If the laws of physics allow something, even hypothetically, the universe usually does it somewhere. Black holes? Allowed by Einstein, they exist. Warped space-time? Allowed, observed. Inflation predicts endless bubble universes. Quantum mechanics predicts branching realities. Mathematics predicts an infinite variety of possible universes. Nothing in physics says there can only be one universe. In fact, the opposite is true. One universe looks too small, too simple, too lonely. Clue 2. The fine-tuning problem. Our universe's physical constants are shockingly precise. Change gravity slightly, stars don't form. Change nuclear forces, no atoms. Change dark energy, everything expands too fast for galaxies. It's like the universe is sitting on a razor's edge. Scientists ask, why these values? Why not others? The multiverse provides an elegant answer. If there are countless universes with different laws, we naturally find ourselves in the one where life is possible. It's not magic, not divine calibration, just cosmic probability. So, are we alone in the cosmic foam? Maybe we're like fish in an aquarium, trying to guess if there's an ocean outside the glass. Maybe our universe is just one bubble, drifting in an infinite cosmic sea, never touching the others, or perhaps subtly interacting in ways we haven't learned to recognize yet. Or maybe, one day, we will develop the technology to detect the fingerprints of another universe. What would it mean for religion, for philosophy, for science, for humanity's place in existence? The multiverse forces us to confront our most profound question. Is our universe the entirety of reality, or just the tiniest fraction of something far larger, far stranger, and far more beautiful? Whatever the answer is, one thing is certain. We are living in a universe brimming with mystery, and we're only just beginning to scratch the surface.